Okay, we are back to the second video for the slope. We are moving on to something a little bit different. Last time we talked about looking at a diagram. If we have a straight line on the diagram, we really want to find out the rise over run because that's the slope. Or we were trying to pinpoint 2 points on the diagram so we can use it. So for this video, it's going to be quite short. We are going to talk about, another way to find slope. Slope is annoying as in there are many different ways that they can present to you as a question. So you have to use the best method. Basically, use the best method for your job. So for this lesson, we are going to talk about if I were giving a table of values. So there's this table with a lot of things in there. How can we find the slope because of using that? So another thing I do want to point out, slope has many different names. Another name is actually rate of change. Okay, rate of change from time to time will show up, and it's also talking about slope. So slope, there are many different ways to talk about it. We could be talking about, well, slope means rise over run. It also means rate of change. Okay, when something is changing, we want to find out how many times it go up on the y value, how many times it goes to the right for the x value. So rate of change sometimes will be representing slope, and I think I've talked about that already. Sometimes we just say slope is m because we don't feel like writing rate of change or slope every single time. So keep that in mind. Slope, rate of change, same thing. If this question actually say find the rate of change, you don't have to worry about it. It's just your slope. So what do I mean by having a table of values? So the x and the y, I just use decimals on this. So the x and the y may be of something different. It could be a question about two scenarios. It could be the distance traveled versus the space is gonna occupy. The x and y may change. It depends on the question. So this x1, y1 over there, it's not really big deal. It depends on the context of your question. So in this scenario, we don't really need to worry about it. We are just going to go for the very simple form of a table of values. So I have the x, I have the y. X will always go first. Y is always going to go second. So there are a couple of things you can do. If I just give you a table of values, at least you should be able to plot all these points. So if I give you the graph paper, I give you a table, you should be able to do it. -3, -4 is the very first point. -2, -1 is going to be the second point. So when we are looking at a table of value, we are actually talking about there are many points that we are looking into on the diagram. So this -3, -4 basically is one of our coordinates. It's going to be -3 and -4. Okay, so if I'm picking out a point, you say, well, I don't like negative number. I want negative. I don't want negative. I will have this 0 and 5. 5 is going to be another coordinate. So all of this, 1, 2, 3, 4, 5, 6, 7, we will have like 7 different coordinates. We will have 7 different points. 1, 8, 2, 11. So we can write all of this out, and I don't have to. It depends on what I want to do with this table of value. If I'm going to plot the diagram, I'm not going to write off these coordinates out. I'm just going to go to the diagram and start plotting -3, -4, 0, 5, 1, 8, 2, 11, and so on. But we are going to focus on something very particular with this. If I have a table of value, there are like many numbers. What I may want to find out is the slope. Okay, we may want to find out the slope for this set of numbers. Now, this set of number, there are a couple of things I want to test and I want to show you. Let's say I have all 7 coordinates. I want to write off them there because I don't want you to be confused. Like, how did you get this 314? So you are reading per row. Each row is going to give me the coordinate system. Okay, so -3, -4 is the coordinate. So let's say if I want to find the slope for all these points, and I may want to double check. Can I just randomly use 2 points to find the slope? That could be a question. Okay, can I just use -3, -4, and maybe I'm just going to use 0 and 5 to find the slope. We want to use this pair of number to find slope, so we're going to get the m. Let's just call it m1, okay? Because I'm not sure if they're going to be the same. So I want to show you that they should be the same. So let's say another set. I'm not going to pick the overlapping one. I'm just going to pick 1/8 and 314 as an example. Alright, and 314 as an example, we are going to call it M2 this time because I really want to find if I have this set of value, if I have this table of value, I really want to know if I will get 2 slopes that are the same, because we may pick something very different. I may be really dislike negative number. I may not want to pick this set. I may just want to pick 0 and 5 and 1/8. Okay, another student may say 0 and 5 and 1/8. Okay, so let's just do a third one. What I want to show you by the end of this is, it doesn't matter what you pick. Under one condition, I do have to talk about that condition though. Under that condition, it doesn't matter what you pick, your answer is going to be the same. The rate of change is going to be the same. So let's say I'm going to pick 0.5 to 11. Why not? 211 sounds good. So I'm going to do that. Let's move this in the middle of the screen. So let's call it M3. So after the last video or whatever we did in class, we should know that we're going to find this slope. We're just going to call it like x1, y1. x1, y1. I'm not going to be very adventurous with this. I'm just going to call this x1, y1, x2, y2. So we're going to deal with this. So m is equal to m1, y2 minus y1. So y2 and y1, they go together. The y's should be on top. So 5 minus -4. x2 and x1, they go together, so 0 minus -3. Then I'll get a nice 5 plus 4. So remember that double negative turns into a plus. 9, double negative turns to a plus 3. 9 divided by 3, 3. Alright, so for my m1, if you can do the subtraction of negative, you can divide 9 and 3, we'll get a nice slope, 3. So let's move on and check the other one. We are not going to do anything different from this one. We are still going to put this x1, y1, x2, y2 over there. Ideally, you should be able to do it without writing off this. So m is equal to, m2 is equal to 14 minus 8 over 3 minus 1. 3 minus 1 is very easy. It's going to be 2. 14 minus 8 is going to be 6. Right, 6. 6 divided by 2 is going to be 3. Okay, that is correct so far. But I don't trust people, so I don't trust myself. So I'm going to try this. I'm going to pick this 0.5 and 211 and check it. 11 minus 5. 2 minus 0. 11 minus 5 is 6 again. 2, 3. There you go. So it doesn't matter how you pick this group of value. So long as you can pick 2 points, you understand the concept that, you know, giving you a table of value, we can turn that into coordinates. Pick 2 of them, do the slope formula, we are going to get a slope. And the slope are going to be the same. Okay, so I really do have to talk about another set of criteria though. What if it doesn't work? You know, it may not work from time to time, and it's under this condition, which we should all know, that if I give you a table of value, we can talk about if this thing, this whole table, I'm going to erase off this, has what we call a linear relationship. Linear relationship means for each number it goes up. Okay, for each number it goes up, it has to be the same number. Alright, so it has to be the same number. So from -3 going up to 2, I'm adding 1, right? From -2 to plus -1, adding 1. -1 going up to 0, adding 1. So for each of those arrows, I'm actually adding 1 per time. Alright? And then we also have to check the y value and see if it's always going to be the same. Now this may be a little bit difficult for some of us, so we are just going to do the positive first. So that would be our easier one. So from 2 to 5, adding 3, adding 3, 8 to 11, adding 3, 11 up to 14, adding 3. So let's go back and double check. -4, add 3, gotta be that. So you can see that for the x value and the y value, if we have the same pattern, like we are always adding 1, we are always adding 3, that's what we call linear relationship. Is going to be not fun to write this relationship. So if we have the linear relationship, then this group of numbers will work. It doesn't matter how you pick the set of number, you can do -3, -4, 3, 14. The slope is going to be the same after simplifying it. Just one really quick thing at the end. If we have linear relationship with a set of with a set of values in the table, we can find the slope. Another thing you may want to spot with this, I just did all of this. You see the slope is always equal to 3, right? The slope is always equal to 3. It doesn't matter how we do it, it's always going to be equal to 3, 3, and 3. For a simple number like 3, we can always say the slope is just going to be 3. Sometimes we like to use the fraction because we may talk about something called like the negative reciprocal. So we may want to put a 1 right over there. Rise over run, right? So rise is 3 times, run is 1 time. So I want you to pay attention to the table of value, like this column over here is always adding 3. Can you see it? So it's the rise, the change of the y value is going to be 3 every single time. And the 1, adding 1 over here is our run. So it's always going to be adding 1. So all of these things are going to tie together. I hopefully will put all of this together in the future videos, that table of value, the graph, and giving you a whole bunch of points, they're all the same thing. It's just like a different way of representing your data, like whatever you have. That's it. That's all I have for the slope. There will be more videos about the slope coming up, and I hope it helps. Okay, bye for now.